Yes.
Okay, so we're going to walk through question 2 on exam prep week 5, going over iterator of iterators. Okay, so how I like to approach these problems is to create a small example, walk through how I would create a solution for that example, and then generalize some pattern. Okay, so the example I have created is 3 iterators that spit out values 1, 2, 0, and 3, 4, 5. Okay, so looking at this example, we're going to think about having a current iterator, or the iterator that we're currently on. Okay, so let's say this arrow points to the iterator that we're currently on. Okay, it always starts off as the first iterator. Then, once we're done with this iterator, it'll move on here, and then kind of keep circling like that, right? So you guys may think, oh, maybe a cool solution would be to use mod and have some index that keeps track of like where we are in the list. That solution could work. It's a bit complicated because if we exhaust an iterator and we remove it from the list, then the modulo kind of gets messed up, okay? So another way that we can approach it, maybe not as intuitive, but it's pretty slick, is that when we're at a current iterator, what we do is we'll remove it from the list. And then once we're done using it, we'll re-add it at the end, okay? Now, we'll continue this process of continually removing the first iterator in our list. We'll take out its first value, and then we'll push it back at the end of the list. Okay? So let's look at it, how that will look in some code. What we're going to do is iterate, or keep doing this process of removing the first iterator from A, extracting its first value, and then pushing it back to the end of the list. Okay? And if the first iterator that we extract doesn't have anything next, or doesn't have anything, as in its has next gives us false, then we won't add it to the end. Okay? So let's kind of see how that'll look in some code. Okay, so we're going to have some while loop. While a dot is empty. Okay, so we're going to remove the first iterator from A. Let's just call that cur equals, I'm going to get rid of this for now. Okay, equals a dot remove 0. Okay, now we're going to check if this iterator that we're on has something next. So if a cur dot has next. So we only really need this check because an iterator that's given to us may not have anything right from the start, okay? That's why we need this initial cur.hasNext. So if it has something next, what should we do with that element? Well, going back to this example, let's say that we're currently on 0. What we probably want to do is remove 0 from this iterator, and then move this one to the end if there's something next. But what are we going to do with the value 0? We should probably store it somewhere, okay? So taking a step back, let's create a list of all of the values in the order that we should spit them out, okay? So outside of this constructor, I'm going to create an attribute of the iterator of iterators class that's going to be a linked list, just because I like linked lists, okay? So we'll create some linked list. What does this linked list contain? It's going to contain integers, okay? And let's just call it list. Okay, now inside of the constructor, we'll instantiate this list, new linked list. Okay, now every time we see a value, we're going to add that to our linked list. So we'll say list.add, and we want to take out the next value in cur, which we can do by doing cur.next. Okay, and then what we want to do is move what we're currently on to the end of the list, right? Move that iterator to the end because it may have values in the future. So inside of this if statement, we will also add a.add cur, right? And the add function automatically adds whatever we're given to the end of that list, okay? So after executing this constructor, we know that we have a linked list that has all of the elements we want to spit out in the proper ordering, okay? So all we need to do now is every time we call this next function, we just remove the first element in our linked list and we could spit it out, right? And then our hasNext function is as simple as checking if the linked list that we're storing is empty or not, right? Okay, so let's quickly add those in. So our hasNext just checks return not list dot is empty. Okay, and then for our next, it's usually good practice to, whenever we call next, we first check hasNext, okay? So you guys probably didn't know this, no worries. If you did know it, that's amazing. We'll say if we have something next, then we'll execute code. Oh, question. Arjun, you want to take the question? I'll keep explaining.
Sure.
Okay, so if we ever call next and there isn't anything next, we should probably throw some error, right? We learned about exceptions. There is an exception in this case called the no such element exception. So if we don't have anything next, what we're going to do is throw new no such element exception. Okay? Otherwise, what we'll do is in the next, it means we have some value to spit out. So we can return list dot remove first. Since it's a linked list, we have access to this function. Okay? Does anyone have any questions?
I have a question. So I see like you kind of assign a variable at first. I wonder, like whenever during test we can access to all the classes that are on the reference sheet, like a linked list class or others.
So if we don't explicit, like we'll usually be clear on the exam, like what you guys have access to. So you guys do have like access to like using linked lists, and if you guys don't, like we'll specify. Yeah.
Okay, cool.
You go over the methods that the list objects have again. It's like add, remove. I don't know if there was other ones. I just wanted to be thorough.
Yeah. So I recommend just like looking this up online. I think online you can just look up like list methods. It'll give you like a pretty comprehensive list. But some other ones are like get is empty size. Yeah.
Yeah, list is actually a common Java library which is used all over the place.
Mm-hmm.
I can like put a link to it in the docs.
Oh, wow.
Sherry Fan's already on it. Be Sherry.
So the way this works, this linked list, does A get completely filled before we even try and iterate through, or does it get filled while we're iterating through?
Okay.
Like, what would be the order of execution?
So whoever creates, okay, one thing I missed, it's at the top, so it's hard to see, is that this iterator of iterators class should be implementing the iterator interface, okay? More precisely, it should be implementing iterator, and the type of the iterator is an integer, okay? And then in regards to the question, whenever we create an instance of this class, let's say we create some iterator of iterators object, we're going to be passing in that list A, right? So A is, we're assuming, is already going to be containing iterators. Yeah. And then Arjun expanded upon that too.
Wouldn't our like type of the class, the like iterator we're implementing, like, because it's an iterator of iterators, so like would it be like iterator instead of integer or no?
So that's a good question. We're accepting iterators of iterators like as our in our constructor, but what this iterator is doing, it's just spitting out integers, right? Like what we accept in our constructor is different than what this iterator is actually like spitting out.
Okay. If we were to like be out like spitting out like iterators, would we just like write iterator inside of like the caret brackets?
Yeah. So
Okay.
yeah, whatever value that's getting returned in our next function, this should be the same as what's up here. That's like a good rule of thumb for iterators.
Okay, that makes sense. Cool.
Yeah.
Thank you.
You're welcome. Okay. Okay, so add by like definition is add something to the end of the list. That's like how the add function works. And we can't use add, I don't think add last is part of the list collection of methods that we have access to, so using add works. Yeah, okay. Any other questions?
Yeah, for these type of questions, would there be like a clear way to do it? Or is it like more free reign? Because I did it in a different way. So like on the exam, it'll be clear that there's only one way to do it.
So for a question like this, it's pretty open-ended. There's many possible ways of solving it correctly. So I'd say on the exam, you could have like many possible solutions. So don't worry if it's like different than how I did it.
Okay, thanks.
Okay, so in regards to the question, how this class works is we first, okay, the question is, don't we like exhaust an iterator and then move on? But I think the question might have been worded unclearly. How it works is we take the first value of the first iterator, then we take the first value of the second iterator, first value of the third iterator, etc. Then we come back, take the second value of the first iterator, second value of the second iterator, and so on. So we don't like exhaust one iterator and move on. That's, yeah, okay.
Another quick questions, are we like, is it a destructive method? Like is A being changed?
Yeah, so it is being changed, right? An easy way to see that is the while loop condition is like, makes it empty. So yeah.
So the real input is also changed because it's like changing the exact content, not just the pointer.
Yeah. So the input is changed, and I think we're allowed to change the input for this problem, so that's okay. Okay. Does has next move the pointer or next? Okay. So when we call next, like it depends on your implementation. So like in some implementation, you could have has next to move the pointer. Here we don't really, it's like the moving the pointer is really subtle because of the remove first. Because remove first, what it does, it just removes the first element and moves the pointer in one like action. So it's like we're not actually like moving the pointer, but it's like this is like subtly executing that, moving the pointer. Okay, so for the sake of time, I'm missing that. Okay, let's move on to the next question. Okay, if you guys have more questions, feel free to send them in the chat. I'm gonna stop this recording.